Okay, so folks, we are going to get started here on our latest Lockstep Technology Group Tech Talk. And we have another good one again. And we've got returning by popular demand, esteemed Laddie Kelly.
Hello.
Not to be mistaken for, a seaman of yore.
Oh,
Laddie is an old colleague of mine from Cisco. We work together, and Laddie's brings to the table a very strong technology background, particularly in wireless and also in Meraki. And over the last few months, he has moved over into the Meraki organization where he can use his talents to the fullest. Uh, I always like Laddie to come on and talk about Meraki and all the ways we can improve customers' networks. There are a lot of great features in the Meraki feature set, and Laddie's very good about walking through the dashboard in a very informal fashion and offering up good tips and tricks on this. We did this back in December, and we actually ran out of time. I think I could turn Laddie loose on you guys for about 3 days, and he'd have all kinds of great things to tell you. So in a minute, we're going to turn it over to him. But before we do that, I want to let you know about our next Lockstep Technology Tech Talk. It is going to be on network access control, and yours truly, myself, will be the presenter on that one. We'll maybe talk about a little bit about different vendors' technologies, but about network access control itself. What does this technology accomplish? How does it accomplished, etc. So please join us for that one. We do not have a date yet for that, but that will be our next topic. And so without further ado, I'm going to turn it over to my esteemed former colleague, Laddie Kelly, and let him give us all kinds of info on how we can improve our Meraki networks. And Laddie, one thing I'd like to hang out there, that if you could answer at some point, I am understanding that Meraki is about to come out with a new capability called Access Manager, which is, I understand it, is sort of a network access control or NAC solution in the cloud. But at some point, if you'd want to give us a couple of bits of information about that solution, that would be fantastic. So I am going to stop sharing and turn it over to you.
Yeah, no problem, Pat. I'm happy to touch on that subject amongst the other stuff we're going to go through. Let me get my desktop shared so you're not just staring at me talking. Please let me know. Okay.
I am seeing your desktop.
You see my desktop. Okay. All right. I will say this. If you notice anything unique about the Meraki dashboard, post Cisco Live US this week, the blue color, you're going to see a lot of changes, y'all. So you're absolutely not seeing Meraki go away. You're just kind of seeing the Cisco branding going to be further, permeating into a lot less green and more blue going to be showing up. But trust me, our roadmap, especially after Cisco Live, way more than we can discuss today, but an incredible amount of I would say a lot of meat on the bone announced this past week at Cisco Live as far as our roadmap. Not just casual, fluff stuff. We've got more and more you're going to start seeing out of this dashboard, and what we were calling it hybrid mode. Now we've even changed the name. It's basically, where does the configuration tasks reside? Is that either directly on the device or is that in the cloud? That is kind of where we're going to be focusing going out, and you're going to see a lot there. We might have that for another session. If you want to have me back to talk about that, Pat, we can do that. Are y'all getting any echo from me on here, or is that somebody else possibly? I'm sounds like somebody
That could
talking.
be me, but you're not causing the echo.
Okay. All right. Sounds like a little whisper or something happening.
Hey, Laddie, you're not causing the echo. We're hearing you fine.
Okay, thanks, bud. I will continue. So let me back up and get re-centered here, refocused on what we're wanting to go over today. And I want to be minimal on the slides, y'all. That's not today. I don't like to do that. 1 second, y'all. Let me try something with my camera. Apologize. Things like having some technical difficulties with my Desk Pro this morning. Can you see me okay?
I can see your deck and I can see you.
All right,
And
great.
by the way, folks, I failed to mention that if you have any questions, feel free to shout them out or feel free to put them in the chat window and I will ask them of Laddie. And also to let everyone know, I am recording this session. And for all of those who are on my customer email list, you will get a link to the recording after it's over. If you're not on my customer email list and you want to be, drop me an email. Or if you would like the recording, send me an email. Okay, Laddie, take it away, man.
All right, y'all. Well, so some of the stuff today, I don't know if you made it to the last session, y'all, that we had a long, very deep first session, what we kind of were wrapping around this full stack network optimization. We heavily focused more on the quality of service aspects and some other basics in our first session. Today, we're going to focus more in switching, some very important areas there. Pat, you gave me a great introduction, so I'm not going to go through all this, but I'm in Mississippi, y'all. I cover the Gulf states. I'm 20 years in at Cisco, and Pat and I have worked together since he was at Nortel. So we were at Nortel prior to Cisco together. So it's definitely been a good friendship and a good run. And thank you for having me back, Pat, as usual. What I want to leave you guys with today, and I'm going to get a little preachy here for a second, but everything we're going to talk about today is to influence behaviors, proper behaviors for what we need to be doing. And I've seen this. There's not a day or it seems like a week go by that I'm not doing best practice sessions or health checks and customers. And as easy and magical as Meraki has made things, and Cisco is improving the things, the way we do stuff, there's still a lot of just basic blocking and tackling. I think people maybe they get so involved in their rollouts. You spend a ton of money. Your schedules are tight. You're trying to just get things out there, get it going. And then the optimization. Well, optimization will come later, Well, yes, that's okay to do that. But sometimes there's things that aren't just optimization. They're things you really should have been doing during your rollout that would have had you doing a lot less optimization and, quite frankly, a lot less troubleshooting and probably chasing random errors and bugs and things around your network if you'd have done them earlier on in the deployment phase. We're going to try to do that. So what I want you to be or learn to be, and this is whether you're running Cisco or anything, this is just a lot of years of me telling, we want deterministic behavior. And pretty simply, I've got a few definitions up there, depending on what kind of, how you like to follow, your definitions of things. But number one, it's just to be predictable. If I do X, then I should expect Y to happen. That is what we want to do. We want to ensure that that's happening predictably. And that way we can eliminate that if upper layer problems happen in the future. Somebody raising their hand, or I raised my hand and AI picked it up. I didn't do that. That was weird. So, think about this, y'all. Everything we're going to talk about today is to make your network more deterministic. And we're focusing on the Meraki approach, obviously, but this applies to everything, whether it's traditional Cisco, the command line stuff you've known for years, or Meraki, or any other manufacturer, quite frankly. So, for today's, kind of in context to today, we're just going to be using the typical campus switching LAN architecture. Now, I don't have little icons for access points plugged into this, but this is a big part of today's business operations, that I touch in public sector. I mean, I touch a lot of education, higher ed, K-12, and gosh, even in government. I can imagine everywhere in commercial too. Wireless is becoming the predominant access method for your LANs. Now, I'm not saying you may right now be sitting at your desk plugged into a switch port. That's not going away. We still have to have wires to be wireless. But what I'm saying is, Cisco alone, most employees are carrying a laptop. They're not carrying, you're not sitting at a desk with a tower anymore. We're very mobile, or we're using our phones, our tablets. And this is a discussion y'all certainly heard for years prior to this. I'm not going to keep harping on that. But to make my point, I, from day to day, see a lot of campus wired networks, switch networks, the investment made in that in time and energy to do that is really just to become a carrier, a facilitator of a wireless network. People are building out switch networks just to facilitate places to plug in and power wireless access points. And most of the business is being done over a wireless medium now. Especially, like I said, in education environments, and I'm sure we can point out a lot of other ones too there. But for today's conversation, let's just consider this basic network stack. Core is where we're going to be doing the routing. Although I know that many people do aggregation or distribution level routing, we can do that in larger networks, but this is kind of a campus here. We're not going to need to route everywhere, but we could do that. And then the access edge, layer 2, pretty easy stuff. So today's agenda, and I'm going to get over into the dashboard. We're not going to spend a lot more time here. Like I said, we're going to focus on this basically one page that you really need to focus on today in the dashboard. We're going to talk about management VLAN, global spanning tree configuration best practices. I should put 5 stars next to that second one. This is the one that I see missed time and time again. Most every call I get when somebody has a problem or they're wondering what's going on and they've got a Meraki switch network or a hybrid network, let's say, of Meraki switches and traditional Catalyst, or, dare I say, you've got, HP switches or Juniper or anything else in there, or everybody admit it. Don't tell me you hadn't done it. Sooner or later, somebody goes out to Amazon and they see that 24 port switch from Taiwan with some crazy name like, Good Joy Switch Company or something like that. And we need a switch now. And that thing's $50. I don't have time to do a purchase order. They're in the networks out there. Everybody on this call, whether you admit it or not, I bet you've bought a cheap switch, something commodity, and used it or leveraged it somewhere in your enterprise grade network sometime in the past, or sooner than later, you're probably going to do it. So we had to think about lowest common denominator a lot of times. Resiliency mechanisms. What are those? A span tree. That's things like root guard, BPDU guard, loop guard. What are those things? What do we do? Trunk ports. If I'm going switch to switch, 9 times out of 10, that's going to be a trunk port where I carry multiple VLANs across that. What are some other things I could do there? Like VLAN permit or deny statements. Let's don't send traffic down these links that's not needed. We call that pruning the traffic. That is a best practice. Quality of service, we've already did that, hour and a half last session on that, but we'll skim right back over that from a switch perspective. Multicast settings, MTU configuration, jumbo frames. That one, I need to spare a little extra time. I've started holy wars, I think, over jumbo frames before. So I'm going to try to navigate those waters and explain a few things on that I think people just go, oh, okay, jumbo frames are on, and you don't really know or consider what that's doing. and then storm control and things like that. So anyway, let's get back into my dashboard. I'm getting ahead of myself here. Escape PowerPoint. Everybody wants to escape PowerPoint. And y'all, by the way, too, everything we're going over today, and I'm going to try to put this in some slides for Pat to share with you guys after the call. You know, a lot of the stuff I'm going over, I kind of, you know, happen to know where it's at just out of repetitive, you know, muscle memory. But we have a lot of good switching guides out there that you just Google Meraki large campus switching best practices. You know, Meraki campus LAN planning design guidelines, best practices. I mean, this goes all into the switching, the wireless, all kind of things there. Great, even model specific stuff, general MS best practices. This really focuses more on if there's any down and dirty one, this is the one to go look at. If your attention span is, hey, I can only handle 2 paragraphs, go to this one. You know, especially if you're mixing traditional Catalyst or Nexus products with Meraki. There's considerations of the way spanning tree gets synchronized across those hybrid domains like that. Some of that's going to be improving in the very near term on our roadmap. You know, until now, I'll say this. I'll wait a minute. I'll get back to that when we get on this. But I'm going to make sure I come back to talk about the difference in the spanning tree on the 2 different platforms. So these best practice guides out here are great, y'all. And I'm going to send you links. We'll copy that. But, you know, switch settings, a lot of the stuff I'm showing you is going to come right out of this, you know, today. So I'm going to get you the links. Google works, last time I checked, just as well for you as it probably does me. You know, I may just have a little more, you know the nomenclature a little better, but, you know, you need to read a little, folks. You know, sometimes I know you want somebody just to come in and make magic happen for you, but this stuff is pretty easy to consume on the Meraki perspective, and it's out there to keep you on track. So now let's kind of get into it and show it in practice instead of me just, you know, pontificating over it. So we're in my home network. And by the way, y'all, before I do this, like I said, you're going to see some things changing. Fundamentally, we're not changing. It's going to look, but you're seeing the blue color is the big standout. You're going to see some things going. You're going to see a lot more being added. You see this slide over here just keeps getting bigger and bigger. Pat brought up Access Manager. You know, that's a new one there that can play into your, you know, right now it's kind of in its infancy. I would almost say it's still, you know, it's very, you know, .0. It's 1.0 right now. So, you know, it's going to get better. Is it a replacement for like full blown Cisco ICE or Identity Services Engine? No, it's not. But can it do some things on a simpler, more, you know, cloud first perspective for you? If you don't have servers on prem, or you don't want to be on prem, or most of your workloads are in the cloud, maybe you're doing Meraki. Well, your workload is in the cloud as far as managing your Meraki network. You're probably already doing things in the cloud like Microsoft Azure. There's 1,000 different services that run on Azure. Intra ID is one of those that ties back to Access Manager. That's what they used to call Azure Active Directory or Azure AD. Now they call it Intra ID. So just like us, Microsoft changes their names on products, you know, to keep some buzz going. And even if they have to re-explain it to everybody, it's one more way to have another conversation. So, but before I dive into this, there's that, but I wanted to show you too, early access on your Meraki dashboards. You can opt in or out of a lot of this stuff. There's Access Manager. this is a big announcement. AI assistant. This is going to be heavily influencing and rolling into our assurance perspective. So right now, this is being rolled out. So you have to opt into it, and then it might not show up immediately, but it kind of just tells the product team that, hey, yeah, I would like to try that out. And, as they go around what we call different database shards around the planet, so to speak, they'll be rolling that out to people who've opted into that. And the AI assistant is exactly what you would expect. It's chat based, or it's just the intelligence of telling you, hey, something's wrong, or something could be improved, or, how do I fix this, or point me toward that. That's what we're going to be doing there. This was a big announcement at Cisco Live. And as you can see, there's a lot of other stuff in here too. Switch device health. A lot of this stuff's been here for a while already. Very, I would say, low impact. If you opt into this, don't worry that your network's going to cease to exist and crash on you. That's not how this stuff works. This is basically opting into features to make them appear in your dashboard. And then you have to go another step further and set those features up, typically, if they're not just informational or observational type features. So,
Hey, Laddie.
Yeah.
One I see there on your screen that looks interesting, particularly for those who are Catalyst folks looking to move more into the cloud, the Cloud CLI for Cloud Native iOS XE. Looks very interesting.
So you're going to get me on a tangent, Pat. Another huge announcement. So you might hear me say hybrid mode a lot, and marketing changes this on us. I hate it. It seems like monthly they've changed his on us, but we're trying to get our nomenclature more quit confusing customers and partners and users of the stuff. What does this mean in its simplest form? Imagine you being able to be in right here in your Meraki dashboard, using Meraki as network management and observability and automation, not just for fully Meraki managed products, but also for your traditional Catalyst switches running iOS. With that turned on, I could open up a cloud command line right on my switch tools, go in there. And now we went from just monitoring, a few months back, it was read only commands on that command line. Now it's a fully operational read write command line. So you'll be able to sit here and manage however you want, all from this one dashboard. There's other wonderful things in there too, Pat, that come along with that, like configuration history. I see a lot of people, there's some people have all kind of money and resources. A lot of people don't. There's many out there that don't have a strategy for even backing up their configurations on their devices. The configuration's just kind of sitting out there, and they're hoping the device doesn't die, and that if it does, they can recover that somehow, or it's on somebody's desktop in a notepad file. We can, we're backing that up automatically to the cloud for you, even on a typical command line switch. Also, revision history. I could sit there and say, here's what the running config looked like yesterday, and here's what it looks like today, and something's broken. What changed? And it's going to highlight what changed in there. So lots of cool stuff in here. Was there a question too?
Yes. Yeah, there is. First question is, does the Cloud CLI need a VM on-prem to connect the switches to the Meraki cloud?
Not at all.
Yeah.
I can't show it. I don't think I can show it on, so I'm on a Catalyst 9300 that's fully Meraki managed, but I can kind of show you what it looks like. So I went into my switches here. I'll just walk it back here. I went into my switch, and you notice we have tools and stuff up here. Here's what we're talking about: Cloud CLI, session history, all kind of stuff here. But watch this: launch terminal.
I like it.
Well, I can't do an enable because I'm in a fully Meraki managed. If I was in a, more of the hybrid mode, I could do enable, config T, all that good stuff. But right now, I could do stuff like, show version on mine. I can only do read only on how I have this switch managed. I need to put I'm in the process of putting another hybrid managed switch into my stack here in my lab. But I think you get the picture. I also can detach that terminal, if I want to just be off in a separate window for it, so I can do different tabs. Same thing, show, run, I can sit and run through my configurations there and look through all that stuff. So, and what you're not going to see on mine here too is configuration revision histories. If I was in the corporate dashboard, I could show you that, but I can't really teach you what I was going to teach you today and be in the corporate dashboard because they don't give me enough permission to break all that stuff. So,
Hey, Laddie,
yeah,
I'm going to pontificate here for just a second. So, because back when I was with Cisco, I was involved with DNA Center when it very first came out, showed a lot of promise, and it's a very good product. Unfortunately, there's a specific customer base that can really handle that heavy lift of purchasing and managing DNA Center, now called Catalyst Center. And I always felt that there was a large group of Cisco's customer base that would, from a management perspective, that were sort of left out in the code. You had the folks in the Meraki dashboard who were well taken care of, then the folks who could consume and manage DNA Center, but the folks in the middle. I really love this movement over the last few years where Meraki is embracing the Catalyst into the dashboard, and I think it's going to help a ton of customers. So I will exit my so
Pat, it's all great conversation. We used to have a product. Yes, I've never thought Cisco was great at a software company. I'm just going to admit it. We kind of sometimes we sucked the least, if that's the best way to put it, as far as managing our products. There was third-party stuff that would do one function or a handful of things wonderfully, but you had to go pay for that, and then you build this toolbox of all these different random tools. We had prime infrastructure. God, that was an albatross at times, but also it did things well at times. Then we came out with DNA Center, and we call it Catalyst Center now. And that is still not going anywhere. That is going to be relevant for people who need to be on-prem or need to be air-gapped or high security, or if they wanted to be a campus fabric, that's the deep end of the pool. Software defined access, Catalyst Center honestly, there's two angles to it. In its base form, it can just be another network management system, an NMS tool for you, backup configs and automate port changes and do things like that. Or the deep end of the pool, software defined access. Well, now I'm going to start pulling in, scalable group tags and east-west control and micro segmentation and all those other fancy words. And then it gets really deep at that point. But due to the very popular demand of Meraki, you're going to see a lot of people said, I want those workloads out in the cloud. Can we do that more? And the answer now is absolutely yes. Access manager is part of that. Meraki adaptive policy is part of that. So many things. It's on the roadmap, y'all. We're going to have a cloud-based fabric where you can go in and even, have a fabric on your campus that's Meraki managed. You could have a BGP, EVPN, VPN set up for your wide area if you want to do that with open standard, BGP protocol stuff. So anyway, we're really getting way down the road. I'm glad people are excited about it. I'm excited about it. Cisco Live was a real high this week, and we're going to be doing more series as y'all that really kind of roll back and show what we discussed. But if I don't get into what I was going to show you right now, we're going to miss kind of the meat of the matter today. So let me get over in here and get back on track and get off the pontificating side. Today, we're going to spend our whole time, the rest of our time pretty much, in this one page. So if you're not a Meraki switching customer and you're on here or user, I apologize. You're going to be seeing some things that you may not touch, but if you have any interest in getting Meraki switching or managing your switching from the dashboard, this would be relevant to you. And also, you know, like I said, there's going to be principles shared today that matter. I don't care if it's Meraki or traditional Catalyst or, you know, iOS or anything else out there. So let's go down the list a little bit. Some of these are easy to explain and some are a little more in depth. So VLAN configuration. Well, what's the first one here? What does this mean? Well, the default is going to be VLAN 1. That's practically any switch that comes out of the box, no matter who made it out there. VLAN 1 is going to be the default VLAN. So my network, I'm still running the default there. I have a small network. I don't need a gigantic thing. I'm not trying to have multiple management VLANs. But in this context, that management VLAN can be anything you want. But you got to remember the switches out there that are wired together on your campus. You know, if I change that management VLAN to VLAN 10, well, then I got to make sure VLAN 10 is present on all my trunks to all the switches out there. Now, by default, that VLAN should be permitted. All VLAN should be permitted on a Meraki trunk. If you've gone and pruned that or done some of the other things we kind of talked about as a best practice, you know, remember that could block that from getting out there. So, and just remember too, you know, this is changing it on a global basis, and it's only changing it on this network. When I change this isn't changing the management VLAN for my whole global organization. It's just changing this for my home network. I've got multiple other networks and locations that could have different management VLANs if I choose, but that's your default. And just remember, that is a quick way to, you know, if you want to use something other than VLAN 1, you can. But part of our spanning tree talk here, the next talk, the important part of today, VLAN 1, especially when I'm mixing traditional iOS driven Cisco, and my AI is just, man, this thing's getting whacked. I was like holding my hand up and it's saying I'm giving a thumbs up right now. It's weird. Sorry, y'all. When I tie a Meraki traditional switch, which runs rapid spanning tree right there, says it right in front of you, it is single instance rapid spanning tree. So there's just one database tree for this whole campus. Traditional Cisco iOS switches and Nexus OS or NXOS Nexus, they run by default what's called per VLAN spanning tree or PVST plus, and now it's actually rapid PVST plus. So what that means is it builds a tree, a root bridge, and then all the designated ports and everything for each VLAN has its own tree built out, instead of just one tree that all VLANs follow. So as for now, when I have Meraki trunked into a traditional Cisco iOS domain on that trunk link, and really all my trunk links, I need to have VLAN 1 available, whether that's your management VLAN or not, but having that available on the trunk links between switches, if you're in that mixed environment, is critical, because that is how rapid spanning tree, the single instance, can synchronize with rapid or PVST plus per VLAN spanning tree on the iOS side. So that is actually in this best practice right here. It talks about, you know, the different stuff. Like I said, I'll share these links, but it does tell you about, hey, if I'm mixing this with different type switches out there, things to consider in that. So, you know, VLAN management. Yeah. What's up, Pat?
I just one of my best practices is I like to recommend, you know, as they say with configuring network infrastructure, there are things you can do and there are things you should do. Although Catalyst environment supports per VLAN spanning tree, to have different topologies. My recommendation, unless there's some very, very specific need, stay with one topology. The real value in per VLAN spanning tree is more the rapid part of it, not so much the per VLAN. So keep it simple. That's my recommendation.
Amen. Keep it simple, deterministic. That's what we're all talking about. Back to our mantra today. Now, here's the good news. Rapid PVST Plus is on the near-term roadmap for the next code releases for the Meraki side. So we will be able to get away from having to worry about single instance rapid spanning tree talking to, rapid per VLAN spanning tree. It'll all just be able to run PVST Plus or rapid PVST Plus once that becomes available, but that is near term. So, but as for now, I've ran into this many times. If we go back to let's go back to the drawing over here, y'all. And if we think about this common LAN here, a lot of times this core isn't a router, it's a layer 3 switch, and a lot of neat things to talk about here. If this aggregation layer, let's say this is Meraki running rapid spanning tree, and then this is Catalyst running iOS XE running PVST plus per VLAN spanning tree. These are the links I'm talking about here. These trunk links need to have VLAN 1 present, so rapid spanning tree can synchronize with PVST on a common predictable VLAN together. So there are some people out there go, I don't want VLAN 1 on my trunks. It's just a best practice. It's an old thing. It's security, and I get it, but there's ways to lock that down. We still need that. And also, if I was running a hybrid here, with this being iOS on this side, we want these to be the root bridge too. So the blue here, the core, we want that to be the root, y'all. If everybody hasn't grasped spanning tree, the core is where we want the root bridge. The aggregation and the access, edge, that's where we want our bridge priorities to get higher, but less importance, if that makes sense. I'm going to get into that in a minute. But once again, just keep this in mind. One other quick note, we talked about, that I showed you that cloud command line, and I talked about hybrid mode and, being able to manage both from the Meraki dashboard. We talked about that. A perfect example of this is this drawing right here. I have customers, I even recommend this, y'all. I prefer layer 3 on Catalyst on iOS. If somebody can handle that, I think you're going to have a much feature-rich layer 3 routing experience on iOS XE. But when it comes to basic fiber aggregation, layer 2, access edge, I'm plugging in PCs, printers, access points, clocks, cameras, whatever. Layer 2, Meraki rules the roost there. There's nothing easier there. So, but if I could sit and now have the best of both worlds, wait, I'm in my Meraki dashboard, I've got all this covered here, but I want to launch into a command line on my MDF switch or my layer 3 core on my campus, bam, I can do that right from that dashboard without having to get out, launch another SSH session or do something other out of band just to get into it. So perfect example of where that cloud command line and hybrid mode is going, and we're calling it something different now, y'all, just bear with me. But, that is where that's a big benefit. So back into this. So let's get right off into the spanning tree configuration here. What we're going to focus on right here that nobody seems to ever, very few people get, is this bridge priority. Bridge priority tells you the priority, the importance of the switch when I create the tree. When I plug all these switches together, I got closets feeding into other closets, feeding into a core, where I got stacks of switches, and I get all the way back to a core usually to be routed somewhere else, whether that's the internet or somewhere else on your wide area network or to another data center. That's how we follow the tree down. By default, every Meraki switch comes out of the box with a bridge priority of 32,768. So the lower the bridge priority, and let me show you a graphic here. You see 0 there. If I do this, and it'll tell you right here, there's a lot of different ones you can select here. 0, the lower the number with spanning tree bridge priority, the more precedence, the more priority you have. If I mark something 0, that is likely going to be the root bridge. It should normally always take over that function. There are situations where it might have trouble doing that, but 9.5 times out of 10, your root bridge, you want that to be priority 0. That's whether that's Meraki or Cisco. Meraki just makes this easy to do all here from one page instead of having to go touch multiple switches on a command line. Consistency is everything, y'all, and being deterministic. What I love about Meraki right here is I can be very consistent. If I can make a change here and it affects all the switches in this campus, they're consistent. Then I know the configuration is right. But as you can see, there's a lot of choices. I can go all the way up to 61,440. And remember what I told you? What's the default? 32,768. So 0 most important, 61 least important, and there's a whole lot of in-betweens in here. Well, why do we have these in-betweens? So let's dig a little deeper here. Back to my slide real quick. I threw some information on here very quickly. Is anybody familiar with spanning tree tiebreakers? Can y'all see that slide okay? So if I have switch A and switch B, and I plug them together, just two switches, and I put a wire between them, plug them together right out of the box, and let's say they're both bridge priority 32,768, their default. Who becomes the root bridge if I don't tell it who is the root bridge? What happens there? Does anybody want to? Pretty easy answer. Does anybody want to jump on that?
Feel free to shout an answer in the chat room too.
You'll get all kind of brownie points if you answer.
Yeah, it's lowest MAC address. Sometimes that's the oldest switch in your environment.
Good point, Sam. Exactly. So, and by the way, is that the Sam Gibbs from North Mississippi Medical Center I knew years ago?
Formerly, yeah, no, Mississippi State.
Dang, Sam, man, it's been a few minutes, bud. I'd love to catch up with you sometime.
Sure,
Great
sure.
to see you. Thank you for answering.
Yeah, this has been great.
But anyway, yes, Sam's right on point there. So if I plug them together and they're both the same priority, there has to be a tiebreaker. Switches, as we said, with higher priority are preferred. If priorities are equal, the switch with the lowest MAC address is selected. And Sam colorfully said a lot of times that's your oldest switch too out there. So if I've got some switch from 1998 still in the network, then God forbid what might happen there. But so part of being more deterministic is this is the part that's not automated for you. This does require some intervention on your side, but Meraki makes this easier than most to do this. So I've only got one switch here, and it's a 9300 switch, and I picked it out of the list. And I said, I want you to be priority 0, which is gonna, I'm not gonna reconfirm it, but I know this is now basically the root bridge of my network because I set it to 0. Now, if I come in and I plug in 2 more switches into that together, maybe I plug those 2 switches together and cause a loop. That is, that's allowable, not great, but you can do it. They're coming out of the box, remember, at 32,768. So if I was going to be a more deterministic setup here, I would leverage my priorities here. So my root is 0. I know by default 32,768. And a lot of people just say, oh, just put everything up here at 61,440. And that never hurt anybody. That's not right. That is actually very lazy advice, quite frankly. And I'm going to tell you why. Once again, it's all hinges on that default. If I go back to that structured drawing I showed you, core, distribution, or aggregation and access, let's think about it this way. Most important is the core, the root, 0. As I back off to maybe my aggregation layer where I might be aggregating a lot of fiber in my closets, or switches into that switch, I want to be a little higher. I might say, you know what, for aggregation layer, I want to go 8192. And then I want to go to my access layer, all the way out at the very edge of the domain, or the edge of the perimeter, so to speak, 16384 for that. Now, I could certainly go higher. You can choose whatever you want. You may have a lot more hops, but in a best practice network, we still try to stay core distribution access. We don't want, I've many times have I seen networks that are core distribution access. That is not good. Does it work? Does life cease to exist? No. But I've seen some daisy chain switch hells out there that you should not, wake up on Monday morning and say, that's how we want to build the network. That is what you should be trying to avoid, unwind, correct, if you can. But so why am I choosing these? If I go back to my drawing here, y'all, let's go back. I think picture's worth 1,000 words. And right here, I'm going to put a text box on my core. I'm going to say your 0 STP root. And then I'm going to come to my distribution layer right here. And I might say, you know what? You're 8192. You're a little less important, but still important. And then I'm going to get out here on the access edge. And I might say, you know what? You're 16384, or whatever I can't talk. I can't talk and type at the same time, y'all. What I'm doing there is making a logical flow. I'm falling down through the funnel point being the root of the bridge, the root bridge, the root of the tree, the most important. So further out to the edge, less important. As I move toward the core, get to aggregation, 8192, I'm a little more important. As I get to the core, I'm 0. What is this doing? This is making my switch network very deterministic, that I know where things are going to be, especially if a change happens. So think about this too, y'all. And I'm just going to put it out there. You don't have to answer. But what I tell you, the default was 32,768 was the default value out of the box. And that's the default for a lot of other manufacturer switches out of the box too, not just Meraki. I've seen a lot that are come out with that. What if I plug that switch out of the box into this network right now with it's out of the box at 32,768? I hadn't told it anything different yet. What happens? Think about that. So new switch comes in the network. I don't care if I'm plugging it in here or whatever. By default, he's 32,768. This is how I like to design my network when I think about this. What that means is any switch new out of the box that I plug into this established network is never going to have a bridge priority more important than even my most lowly access switch out there, and especially not my root or my distribution. So I plug that new switch in. I'm growing my network. I'm 32,768. What do? Well, I come right back to my dashboard here. I've got another switch coming in the network. I go in here, I pick it. I don't have a big enough one to pick for you, but let's say it was this switch. I picked the switch out of the list. He's at 32,768 by default. I'm going to go on and say he's a new access switch, and I'm going to make him 16384, and I'm going to go on and confirm that. And it is going to say, if you save this, hey, it could be disruptive. So do know that when you're tweaking spanning tree, you could cause blip. So this isn't something to do casual in a well-established large network. I would save this for a change window. Usually it's just going to click it and it's going to happen within seconds and nobody even knows it. If you want a wildcat on your network, go for it. I don't own your network. I don't work for you or your boss. Do what you want. But I have to be a good citizen and say, if you're doing spanning tree changes like this, really you should save that for a change window. Don't do that on the fly unless you just really think you need to. So does that make sense, y'all? Are we kind of okay on that? This is one of the most important things today I want to leave with you is this one thing there. The other is important, but day after day after day, I see people buy millions of dollars worth of Meraki networks, and then they never go in and even touch this. Everything will still be sitting there at 32.768, and they wonder why one switch isn't talking to another, or they got something weird going on, or something's not reachable. And this is stuff.
As I like to say, Laddie, friends don't let friends use default spanning tree parameters.
Yeah, absolutely, man. And like I said, if we cost things out like I showed you and use that logic, anything that's coming out of the box 9 times out of 10 is going to be a higher priority, even if it's default, so we're safe there. So think about this too. Like I said, somebody might have told you, oh, just make everything, way out there on that 60, out in the 60,000 range, like we talked about. You could, go out here and put it out at 61 and it won't hurt anything. Well, yeah, that's minimizing possible effects there. That's certainly not going to take over much of anything. But the thing is, if I plugged in a switch by default, it had to come up at this priority before I could even go in there and change it to 61,440. So it's chicken egg there. So that's why my strategy of telling you the way I cost things, I think will save you a lot of headache and definitely make your network more predictable and your switch, priorities and connections there. So let's move on down here to quality of service. Like I said, we spent an hour and a half together, maybe more. I run my mouth too long last time. We went across this, but some brief things I would bring up here. This is where, you can add quick down and dirty rules. They kind of look like an access list. I could say any VLAN, any protocol, TCP, UDP, or any, I can do a couple of things here. I can trust the incoming diff serve code point, and I would go back, to the last thing. We don't have time for me to discuss diff serve today in depth, y'all. But diff serve is how we put markings on IP packets to set priority. A diff serve code point is all it's doing is putting a marker on the header. It is not enforcing quality of service. It's just marking or coloring the traffic. What happens is we have to mark the traffic so we can identify it and then apply a policy to it, like a different queue. So what are we doing here then? So as you can see, I've got a couple of VLANs here already in my network, VLAN 60 and VLAN 50. VLAN 60 is my surveillance network. That's where my video cameras for security are plugged into. VLAN 50 is my voice VLAN. You can see right here, I went in and said, you know what? I want to set, this is my voice VLAN. Anything on here needs to be expedited forwarding or diff serve 46, EF for voice. Quick, easy way to do that. Another way to do this is, let's talk about it from this perspective. Right here, this first rule here, quality of service by default in the Meraki, I've got it checked here, but by default, this trust incoming diff serve code point, let me cancel this, is not going to be checked. So what happens there? Because there is this rule, none of these rules exist in the default, stages of your network. When you look in here, think about, does anybody have do you farm out your voice over IP? Do you have phones on your, maybe it's WebEx calling. I hope it is. We got a great product. But it might be another, it could be AT&T, it could be, Cox Cable, it could be anybody that provides, hey, a local service, and it's IP based, and we're going to plug it into these IP phones into your network. But a lot of times, like with WebEx calling, especially the Cisco phone, by default, at that phone, we're going to be saying mark the real-time stream, the voice protocol at 46, and then the signaling protocol is going to be like in the 34, I think, if I remember correctly. But that's being marked by default on that phone. Well, if your network, the switches you plug that phone into, is not aware of that diff-serve code point that application's marking, it's not doing anything with it. It's just putting that phone traffic right into the same default queue somebody watching Netflix is on, or somebody downloading a gigantic file, or moving some kind of data backup. So in that instance, if I have somebody providing me my phones, or even they are my phones, I might want to just say, you know what? I want a rule for any that says trust my incoming DSCP, and mark that accordingly. The other reason I do this, I trust that, is because I'm doing Meraki wireless. Back here, we went over this last time. If I go back into my wireless traffic shaping, and I'll show you this, I go down here and mark all my traffic. This was our last session we did. There's my SIP voice, Wi-Fi calling, mark it 46. Broadcast video for surveillance, VoIP and video conferencing. That would be WebEx or Zoom or Teams or whatever. There, multimedia conferencing, low drop. These are my markers. This is my diff-serve markers. So if I'm coming onto that access point going into the wired network, well, then I'm seeing these markers. If I do not have this rule added right there, if I'm not trusting the incoming diff-serve code point from those APs, all that traffic that was marked just goes right back to 0, which is best effort or default. To put a little more picture around that, right down here, edit the map here. This is some of the stuff I go by. This is recommended. I go by the RFCs, the IETF. I use Cisco best practices. This is not the default setup for diff-serve to queue mapping on Meraki switches. This is what I recommend, because it maps well to both Meraki wireless and the Meraki MXs, if you're using those, even the security appliances, or maybe that's your internet gateway. But as you can see, if I don't trust anything, it's all going to be DSCP 0, and it's going to be thrown into a lump best effort queue. And all these other queues in my switch network, I'm not going to be using. But if I trust it, and that phone says, hey, I'm 46, Mr. Switch, I'm voice. Well, what's it going to do? It's going to put it in hardware queue number 5 on the Ethernet port. So every port on every switch has these, 6 queues on it, 0, 1, 2, 3, 4, 5, 5 being the most important, the highest priority. I recognized 46 coming in, whether it was off the wireless or maybe it was a phone plugged right into the switch. And bam, I said, oh, I'm trusting that. I'm going to trust it, and I'm going to put it into QoS Q5, which is more important than any of this other bulk data stuff or somebody going to YouTube or whatever. But unless I add this rule and I trust that incoming DSCP, guess what? Like I said, everything's still right there in the old best effort bucket, all coalesced together. You're not taking advantage of all the queues you have there. Mission critical stuff like voice over IP, your video, like the WebEx we're on right now, may be in a best effort bucket with everything else. So, I often go in, do health checks with my customers and with people, and I see that they don't have this rule or they're not trusting the incoming, yet they may actually be doing WebEx calling, spending millions of dollars with us on our phones, plugged into Meraki switches and no QoS applied at all. Didn't even know they weren't doing it. They just thought it was working because, bandwidth covers a multitude of sins a lot of times. Not all the time, though. Sometimes, things can still get in a queue and take that up, starve that out, no matter how much bandwidth you have. So this is an important part. Remember, these rules I have in here, I created. It's easy to add a rule. If I wanted to say anything from VLAN 20, which is my guest network, I'm going to say it's any protocol, I'm not going to trust it, but I want to say it's, we'll just say it's transactional data. I can save it that easy. That was pushed to all the switches. That policy applies to every Meraki switch in this network now. Back in the day, what did I have to do? I had to go telnet or SSH, not telnet, I'm really showing my age. SSH, get in every switch on the command line. And then I had to go in there and set up, class maps, policy maps, access list, all that stuff. And then, man, I cut and paste away all day long, going switch. Consistency starts falling off. Things start getting missed. Things start getting, squirreled away. Big win for Meraki here, all in this page. I just leveled that QoS policy across all my switches right there in one spot. It's taken me longer to explain it than it would take you to implement this and improve your network. So any questions on that, guys, before I move to the next part?
No questions in the chat window, and just a time check. We've been going for around an hour.
Yep. I was just looking.
Yep.
We got till 10:30, right, Pat?
Laddie, we have as long as you want, man.
Yeah,
I'd
y'all
say
be
about
like,
10:30. Yeah.
I'll be like, oh God, I'm ready to be like people falling. I'll hear heads clunking on their desk.
Gotcha.
So we're gonna get through the rest of this a little faster. Multicast settings. This is pretty easy, y'all. Just like spanning tree, I can change settings switch by switch if I want to. Usually I'm not doing that. Usually I'm kind of more of just global multicast for this, for this whole campus or this whole network I'm working on. But the defaults are going to be IGMP snooping is going to be enabled in a Meraki switch. And then also right here, flood on multicast, right there, you're going to find that enabled. So this is the one I want to point out that I'm not in love with. Anytime you see the word flood in network, not good. Just that means you're doing something, as a last resort is a better term for flooding. Flooding also happens when a MAC table is exhausted or a route table. The CPUs go into panic. What do? I start sending everything out every port instead of more prescriptively saying multicast only needs to go out these 5 ports on this 48 port switch, as only 5 people are tuning into it right now. Flooding is saying, I don't know what it is, just send it out every port. That's fine. You'll get by with that in a smaller network. Sometimes this is required. I have customers that have legacy paging applications, paging gateways and stuff on a very old system. That a lot of that type stuff on, voice over IP paging is multicast based. And some of those older systems will only work with flooding, but anything really, I would say newer than a decade or newer. I mean, you had to have really old. IGMP is where it's at. IGMP is layer 2, but this is where basically a switch says, I'm only going to pay attention to the multicast stream if somebody's requesting it. That's not really the best way to look at it without getting into the weeds on it. IGMP is only going to send multicast where it's asked for instead of flooding it out every port. Back to my point here, in a smaller network, this can cover a lot of sins, and people go, oh, it's just working, and that's fine. But as you grow this network, I see layer 2 domains in these campuses, or even a school or something, get very big, like wall-to-wall VLANs around the campus and things. They haven't trimmed that down. As that layer 2 domain gets bigger and bigger, this gets messier and messier here. So my strong advice, and you'll find this actually in some best practice guides too, is to go in there and turn that off. Once again, turn it off. I don't know every one of your networks out there that were on the call, just intimately. I don't know your network. I don't know what you're running that might need that, something legacy, but I always try to recommend turn that off, especially in a new network I'm rolling out. Then if something breaks, if it doesn't work, we go back and we can turn it on, but we'll be able to see why it's not working. We'll know we need to flood something. But like I said, most any multicast technology, 10 years or newer, actually older than that, should be able to cooperate with IGMP just fine and not be flooding stuff out like that. So, like I said, flooding is never a good word to read when it comes to networking. It's a last resort is what it is. So anyway, enough on that one. IGMP snooping should be enough. Turn this off if you can, to trim down a lot of unneeded traffic or potential for headaches with that. On to this MTU. This is where I have a propensity to get a little preachy. And like I said, I may have caused some holy wars on this before, but I'm going to show you. I'm going to walk you through my my mania here of why I focus on this. If we go back to our design here of this campus, most campuses I see follow this collapsed backbone, strategy here. We go from access to distribution or aggregation to core, and then we route out. Many times the other side of this router, it may be to another location in your wide area network if you're a larger operation. It also could be straight to the internet, which is very common. What happens is, we talk about MTU size as maximum transmission unit size. The traditional lawful MTU size for the Ethernet standard created years ago is a 1500 byte MTU payload. Now, there will be excess added on that for headers and frames for, the way as things get stacked on, that could be change. It's bigger than 1500, but the payload is 1500. The payload being the data that's actually the work is happening on. The header stuff is just what we're using to say where stuff needs to go or where it's destined, source, destination, quality of service, things like that. Along comes quite a few years back, the concept of what we call jumbo frames. Now, we don't call it that here in Meraki. It just says MTU. And you see mine is set to 1500. But by default, out of the box, I'm going to go to this document and show you. For a Meraki switch, the default is 9,578 bytes. And that's for traditional MS. So I think you're going to start seeing where I get a little, I don't love jumbo frames that much. Jumbo frames make a lot of sense in a very predictable data center network. Maybe I'm moving large data backup server to server. They're all sitting in the same VLAN. Everybody participating in it can know what the same, MTU size is. They can take advantage of that. They're slightly more efficient there. There's argument around jumbo frames. Go to Wikipedia, it'll tell you all about it. But what is a jumbo frame? Maybe I should back up. 1500 byte payload is set by the IEEE 802.3 standard. Jumbo frames is really anything larger than 1500. And that's the other problem. Nobody has ever decided what that is. We kind of say the target is normally around 9,000. When I first saw jumbo frames come out, and Pat, do you see a something here that looks a little familiar? A name? Alteon Web Systems. That might ring a bell from the Nortel days.
Absolutely, Alteon.
They kind of came
So
out and said, hey, we could move more data in a chunk than we're doing. And so back then, I mean, I saw first time I encountered jumbo frames was with iSCSI storage, and it was 4,000 bytes or 4,400 or somewhere in there. And then we started turning the dial up. Well, let's make them bigger and bigger. So that's the problem to me that I see with it. I'm not crucifying it. I'm just pointing out some things to consider. We can talk about bandwidth efficiency all day long. And maybe I went from a 95% efficiency up to 99%. But that 99% with jumbo frames is only if it's in a perfect vacuum with everything identical and everybody recognizing the same thing, and there's not any discrepancies there. I can do that on a data center VLAN, server to server. I can control that. But when I get out into a campus, when I get out and I reach a routed point on the campus, I'm going to route somewhere, VLAN to VLAN, or I'm going to the data center, or I'm going out to the internet. Guess what? Internet don't care about your jumbo frames. You're back to 1500. When you hit that firewall going 5 million miles an hour with your jumbo frame, it's going to do what we call fragmentation. It's going to fragment you back down to 1500 bytes before it sends you out through that routed interface. And the same thing applies to any routed interface in your network when you hit a layer 3, unless you've told it differently, unless you've gone in there and said, okay, I want the jumbo frame to be this. I'm going to support that. And there is consideration. So I don't want you to think when I say an MTU size is 9,000 bytes, that doesn't mean everything waits till it's 9,000 to ship it. It says as long as it's up to that or smaller, it fits, it's okay, and it ships. It's like, was it FedEx or UPS? If it fits, it ships. That's kind of what we're talking about with MTU size. But once we get over that size, then that's when we start having errors on the switch network. A long time ago, if we got over that 1500 byte MTU, we used to call that a giant error until jumbo frames come along and we grade the area. But back to my point here, let's look at just Meraki. By default on the MS switch, 9578. But let's read here in this blue box. The maximum MTU size on the MS 425 is 9416. Okay, so MTU size, here's your math to do it. 22 byte header, blah, blah, blah. It should be this. Maximum MTU size on MS 390, Catalyst 9300 is 9198. Even Cisco doesn't agree on our own jumbo frames. It's product to product. Then I go manufacturer to manufacturer. It's all over the place. Like I said, the IEEE has never come out and said a jumbo frame is this and everybody conform to it. It really should have happened. I don't know why it hasn't happened for all these years, but this is a problem I have when I talk about deterministic networks, especially in a predominantly access LAN. So let me land the plane and get a little deeper while I'm being real preachy about this. In a data center environment where it's controllable, jumbo frames are your friend. Do it. Data backups, do it. The efficiency is documented. It's there. But when I'm going across a LAN with a lot of different things, especially a mixed environment, mixed model switches, maybe mixed manufacturers. Oh, back to that cheap switch you went and bought during the heat of the moment off Amazon and plugged into your network that we don't know who made it. We don't know what that's jumbo frame enabled or not. We have no clue what it's doing. We got to think about lowest common denominators there. So let me show you one other thing to consider here.
Yeah. Hey, Laddie, one thing I'd
Yeah.
like to add to what you're saying, so it's all spot on, is that you had mentioned about if the MTU and the outgoing interface is too small, the router will do fragmentation. But sometimes applications have what's called the do not fragment bit set, which means that it won't allow the router to fragment the packet, which means that your application will break or could break if you're attempting to run jumbo frames. Something to think about.
There's that. And then there's actually some applications have an elegant feature called Path MTU Discovery. It'll say, it looks like PIM TUD.
Yep.
So what Path MTU Discovery means is I'm on my laptop, I'm running an application, and I'm going to another destination across a network, multi-hops. It can determine hop to hop from source to destination and back, what's the common denominator the MTU should be set at, and do that. Here's the trick, though. Not all applications support Path MTU Discovery. So there's that to think about, too. A lot of things are just lowest bidder, y'all. They don't think about things like that. Some things do have that. Also, when I'm pointing this out with this slide here, I'm going to go a little deeper to my madness here. Just because I can determine what the common denominator MTU is, even if I had Path MTU Discovery, that does not take into account a lossy network or a lossy medium. And I have it right there. So this should be an easy answer, y'all. We use them every day. I'm on one right now. What is the most common lossy network you think you could be on right now? Or potential for error and retransmission?
I would say a mobile network or a wireless network myself.
There it is, man, right there on the top. So thank you, Otis. Wi-Fi. So remember what I said earlier today? I have people deploying millions of dollars of switches really to just be the plumbing for their access points now. We're in predominantly mobile access networks, y'all. And those three things I put there as considerations are important there. And a lot of people don't know this or don't think about it. And they just say, big MTU, jumbo sound good. Turn jumbo on. Do this. And heck, we even have it on by default. And I'm disagreeing with what we do. I'm disagreeing with people that are probably smarter than me, but I have the right to do that. And why do I do that? Once again, most people are accessing their networks via wireless. In Wi-Fi right there, retransmissions occur when data packets are resent due to unsuccessful delivery or corruption. Happens for various reasons, including interference, collisions, poor signal to noise ratio. Excessive retransmissions negatively impact Wi-Fi performance by slowing down data rates, increasing airtime usage. It happens when you roam, y'all. You're talking on the phone. You're doing an application. You roam from one AP to the other. It's going to retransmit. It's going to drop something. You don't notice that. But guess what? As we flow down the chart here, think about what a jumbo frame is. A 9,000 byte jumbo frame or 9 kilobyte jumbo is 6 times as large as the largest standard Ethernet frame, 1,500 bytes. So at the same bit error rate, jumbo frames have a 6 times higher chance of having an error. And when that error happens, the whole 6 times larger frame must be retransmitted. So there's that. Where would I worry about this? Well, I just helped deploy a SEC football stadium with 1,000 access points in it with 70,000 people in there with mobile devices. It's high density as it gets. It's as challenging an environment as it gets. I have to worry about all that. I got to get them on and off as fast as possible. I'm using every resource I have. If I've got somebody that's likely going to induce and have an error moving around a concrete bowl or a sports venue or a high density area, trust me, there's retransmissions happening. If I'm waiting for jumbo frames to tee stuff up, well, man, that's cumulative. My whole network became less efficient. And also finally there, if it's a latency sensitive packet, think about voice, video. If it's being queued up behind a full size frame to access the medium, takes 6 times as long to get on the medium in that full size, that frame rather than a 1500 byte frame. So back in the day when we used to do best VoIP QoS a long time ago, we tried to chop it up to make the packets smaller on purpose because of the sampling rates at 20 milliseconds. It's more conducive to have smaller packets so you weren't fragmenting and you could get things through quicker for real-time stuff. So once again, I'm not here to crucify or vilify jumbo frames. I'm just wanting you to think about it in the context of your network. And back to the Meraki side, what I'm really beefing about here is in mobile access networks. So ask yourself, is my network mostly being accessed by wireless, or is that a huge part of it? If the answer is yes, it's not going to hurt you one bit to change that back to 1500 bytes there for your default. The default is every switch inherits this. I can also go in here and you see, I picked a specific switch and I said, your MTU is 1500. I could say also, if I was using some of these switches are data center, I need jumbo frames. Okay, well, I'm going to go in here and I'm going to set them to 9000. And I could be prescriptive on what switches to do that on. So once again, use that to your advantage, what I'm showing you. Back to the point, if you're going to leave it at default and you're a high density, predominantly mobile access network, as a propeller head, I see smaller MTU sizes as an advantage. Now, Wi-Fi MTU size, quite frankly, is around 4,000. It's a jumbo frame in itself, but it acts a lot differently than the way frames do on a wired network. Once again, retransmissions are just part of Wi-Fi. But as that propagates across a network or interrupts applications, there's a domino effect that can happen there. So consider that, y'all. And remember, you can do more. You don't have to just do default everywhere. I've got a one switch network, so I'm just going 1500 here. Also, most of my applications where I'm sitting, it's not just about I'm getting on via Wi-Fi. Back to my point, I'm going straight to the internet. Majority of our workloads are now as a service. It's Azure, it's WebEx, it's Google, it's you name it out there. We've gone cloud heavy on stuff. And the second you hit that routed point onto the internet, you're fragmented back to 1500, whether you liked it or not. So, you could go 5,000 miles an hour head first right into the brick wall if you want to, and have other little nuanced problems. But anyway, I'm going to get off my soapbox here. Like I said, I've created some holy wars with this one before, but that's my sermon on it today, y'all. So let me move.
We've got just a time check. We've got about 5 minutes left. Mm-hmm.
And we're about to wrap it here, Pat. This one, storm control, very important, y'all. By default, this is not going to be on. I will tell you this. If you just, go read up on it, do what you want without me over explaining it, go in there and set a rule for all three of these and set it to 25% available bandwidth. You can do discreetly. I could say, I just want broadcast or just multicast or unknown unicast. Those would be what, any kind of storm of that. That is overhead traffic beyond the usable data or the good put data on the network. What we're doing there is saying, I'm going to say no more than 25% of my network bandwidth can be used for any of those protocols. Think about this too, y'all. That sounds like a lot. Slowest port on my whole network's a gigabit. I got 10 gig. Now we got 40, 100 gig. All over these campuses. 25% of even a single gigabit's 250 meg. So giving 250 megabits per second bandwidth available for broadcast to happen, just to synchronize things or multicast, that's not really hurting anything. So best practice would be to put that around 25. And what that says is if anything got out of control for some reason, it's not going to starve out your switch processors. It's going to allow some room for management traffic to still flow on your network, usable data to still flow from other things, and not choke out and force the switch into back to what we talked about, a flooding condition. So broadcast storms and these kind of storms can cause another type of flooding condition when a switch goes into panic, doesn't know what to do, and it starts sending thing out every port. That also can be phantom spanning tree issues. I've seen it happen because of that as well too. Wasn't spanning tree, it was just because the switch was overrun and it thought it was spanning tree. So that's an important one, y'all. This is just a down and dirty, easy one to safeguard yourself. And then last but not, last, and I would say probably the least, because it is on by default now, but network client sampling, when I go over here in Meraki and I look at all my client data, and I'm all this stuff that shows up here, all my traffic analytics, and I'm fingerprinting everything. Here's everybody on my network, where they're attached, what they're doing. That's what that is. And like I said, you really shouldn't even have to worry about it now, but on older code, you did have to go in here and turn it on. Now on the newer code, it's on by default. What that's saying is exclude the sampling data from your uplinks, that's switch to switch. And it's saying just get the sampling data off the switch the client's on. Because what happens if I sample it on the port the client's plugged into or accessing and I'm sampling on the uplink on the trunk, I'm going to get duplicate data, and it makes those things bigger and more inaccurate. So that's why we're doing that. Like I said, if you're on something on an older code, think about that, or think about getting to the newer code where this is now the default, and that will be your friend there. So that was the gist of today. Pat, did you want me to spend another 5 minutes on Access Manager? Or I know we're right at the end here.
Yeah, we're kind of right at the end. I tell you what, at a later date, once Access Manager becomes a generally available product, I would love to have us come back talk about that. That just looks very promising.
Absolutely, man. And like I said, it's right here, y'all. The gist of it, where it's at right now, is the ability for one cloud to talk to another cloud. Instead of me having a Radius server stood up or a VM here in my house or on-prem in my data center, a lot of people have their directories all over in Azure. This is my personal Azure account here. I'm in Intra ID right now, which is Active Directory. But as you can see, all I'm doing here now, the main thing we're doing with Access Manager, I have a very simple user database. Only got 2 users in here. But what we've done with Access Manager is now cloud to cloud via API. I can synchronize my dashboard straight to the Azure LDP or the Intra ID database. And as you can see right here, now my dashboard is aware. It knows my user database. And now I can go into wireless networks and things doing access control there and say, you know what? The policy object I want you to point to is Access Manager. Go look for it there. Don't look for it here locally or somewhere else. So, and this is going to be growing too, y'all, around adaptive policy. So scalable group tag. There's things that ICE still does that this can't do yet, but it's getting there. This is, to me, going to be the ICE light, especially for somebody who is leveraged into the cloud side workloads, Meraki, and wants their stuff in the cloud, not another server in the rack, so to speak. So anyway, we'll get back on that later, guys. You want to do another session on it? We'll dig in on it, Pat. We always got plenty to talk about. So.
Absolutely. Well, Laddie, this was great information. I much appreciate you coming on again. Always a pleasure, always very informative. Folks, I don't see any questions out there. But if you think
good.
If you think of any questions, feel free to send me an email and I can get them to Laddie. And also be looking for our next Tech Talk. That's where we're going to dive down into network access control. And I'll be coming back to you on the dates for that. Again, if you would like a link to the recording and you're not on my customer email list, please send me an email. I would gladly forward you the link. So I hope you all have a great remainder of your day, and we will see you on the next Tech Talk. Thanks,
Pat,
folks.
Pat, can I say something real quick? I messed up your
Sure.
outro, man. These slides, y'all, I'm going to get them to Pat so he can share them out with you. And I'm going to add some stuff to it. So I'm going to add some of the screenshots I showed you. So I like to be able to see the screenshots. Beauty of Meraki. Just copy this screenshot. Here's the best practices instead of looking it up. And I'm going to put the links to those best practice docs. So you'll have this too, folks. I like to leave that behind with you so you can read at your own, on time. So thank you all so much for the time today, Pat. Loved it.
Thank you, Laddie.
All right, guys.
Y'all have a great day.
Great day. Bye-bye.